everyone. Welcome back to the seventh lecture of this series and third lecture of the chapter Overview of Patterns. So in today's lecture, we will continue our previous discussion where we were discussing about competing updates. If you haven't watched my previous lecture, I would highly recommend you to please go and watch those lectures before this. Moving forward with this lecture, let me quickly recap what we have discussed so far. So in the previous lecture, we discussed that we had two users trying to, Iles and Bob, who were trying to update the same data from two different nodes. If we update the data according to their request, we will quickly go into an inconsistency hell. But to fix that, we were using a technique called leader and followers, where one of the node is marked as a leader and others node are marked as their followers. So in this case, the leader will handle all the updates and then broadcast those updates to their followers, right? So let's say Neptune is the leader in this cluster, then Jupiter will forward the request to Neptune, and then Neptune will decide which operation he wants to do. In this situation, it just processes the Bob's request and rejected the ILS request saying insufficient widgets. So things were going fine, everything was working as expected. But we have to also think through what happens if something fails, like the leader fails. How we make sure that everything works even after the leader fails. So for example, we have Neptune as a leader and Jupiter and Saturn are their followers. So for example, in this case, we got the Bob's request to Neptune and Jupiter request to Jupiter. Jupiter sends its request back to Neptune to process it. And Neptune actually processed the first request and then sent the replication message to Jupiter. But while the time it was sending the replication message to Saturn, it crashes, right? But now Saturn doesn't know that Neptune had crashed and it can't keep waiting for the response from the Neptune. So how we handle that, like Neptune has crashed, how the Saturn will know that Neptune has crashed? So for that situation, we have a heartbeat and also heartbeat timeout. So during that timeout, the Saturn will await for the response from Neptune. And if it doesn't get any response during that time, it will consider it as dead. And then it will go for a new leader election. Okay. So how the new leader election happens, like the replication message got to Jupiter, but Saturn didn't got any of them. So when the election happen, we'll see that Jupiter has log index of 1, but Saturn has log index of 0. So log index is nothing but the latest log that it has. So for example, Jupiter has two logs, which is the replication log 1, replication log 2. So this will be considered as the most updated, and Saturn will have no logs because it didn't got any logs at all before that the Neptune crashes, so it doesn't have any log at all. So in this case, Jupiter has the most updated log, so we'll consider Jupiter as a new leader, and then it will replicate its log to Saturn. Now we were in a situation where multiple failures happen. How we handle those? So for example, we got Bob request and log got updated to index 1 because we got the first request. But in this time, before sending it to Jupiter, Neptune fails. So both of them are still log index 0 and log index 0. And Neptune is at log index 1. So when the election happen, we'll see that both of them are actually similar at similar position like log index 0. So we can elect any of them as a leader. So for example, we elected Jupiter as a leader, new leader. Now Jupiter got the request from ILS for A1, right? 30 widgets moving from Boston to London. So now it also have log index 1. But before it replicates this message to Saturn, it also got crashed. So now Jupiter also has log index 1, which is from request A1, and Neptune also had log index 1, which was from B1. And Saturn had log index still 0 because it never got anything and it also got crashed. So now when we came through a new leader election, which one will get the new, which one should become the new leader? Because both of them are having equal amount of logs but for different data. So this is what it's written here. In a while, Neptune and Jupiter came back, but before they talk to Saturn crashes. Neptune is elected as a new leader. Neptune checks with itself and Jupiter for the log entries. It will see two different separate requests at index 1. The one from Bob, which it has accepted, and one from ILS that Jupiter has accepted. So Neptune can't tell which one it should pick because both of them are having the same label of index. So to solve this kind of situation, we use generation clock. This is number that increments with each leadership election. So whenever a new leader get elected, we increase the generation by 1. Basically increment, just incrementing, and this is very key requirement for leader and follower pattern. So now in this case, right, in this case, when this will get the first request from B1, it will have a generation 1. In the second time, when Jupiter became the leader and it got the new request, it will consider at generation 2, right? So new leader incremented generation. Basically happening here is the new leader first incremented the generation from number 2 to 3 now, okay? But before accepting any new client request, the leader checks the log for all the available nodes that it has for any entries that haven't been replicated to the majority quorum. So these are considered as uncommitted log, which are not into the majority quorum, but they are there, like the logs are still there. So if it's find any conflicting log entries, I mean the entries at the same index but from the different generation, the leader discards those entries and keep one of the higher generation number. Okay. So the leader then overwrites the uncommitted entry in its own log with the current generation number and replicate it to the other nodes, ensuring all nodes in the quorum have the same and correct entry. For example, we can see in this diagram. So what is happening here is basically, so Neptune is the leader with generation 1. Okay. Bob sends the request to Neptune, but the connection between Neptune and other node has been disconnected. So because Neptune heartbeat is no longer being received by the other nodes, the heartbeat timeout occur, and this will trigger a new election and Jupiter will be chosen as a new leader. So this will create a increment the generation number from 1 to 2. So now Alice sends a request to the new leader Jupiter, and Jupiter processes the request, replicates it to Saturn, and also send an acknowledgement saying okay. Okay. So the connection to the old leader Neptune is now restored, and but Neptune is unaware of the election, and it attempts to send its previous request to the other nodes, still using the previous generation 1. But Jupiter and Saturn are now operating on the higher generation number, which is generation 2. So they immediately recognize that the request is from a stale leader because generation 1 is actually lower than what their current generation is. So they will basically reject this request and send back an error message indicating that the current generation is now 2. But you might think, hey, what happens to the Bob's request? How we are handling that? So basically, it is now discarded. So there is another mechanism that we are gonna learn in the later lecture that will fix this problem. But for now, this is how it ensures that any actions from a former leader who was temporarily out of the touch are ignored to the rest of the cluster, which will prevent any kind of inconsistency. So the generation clock act as a defensive marker of the authority. So only request from the highest generation will be considered as valid. Now we need to understand that the log entries cannot be committed until they are accepted by the majority quorum. So in this diagram you can see that like Bob sends a request to Neptune. Okay, Neptune is the leader, first adds the update to its own local log. At this stage, the update is uncommitted because it hasn't been shared with other nodes. Then Neptune sends replication messages to its follower Jupiter and Saturn. Neptune receives the reply from Saturn. Now, two out of the three nodes, which is Neptune and Saturn, have acknowledged the update. So this constitutes a majority quorum. So at this point, the update is officially committed. Neptune applies the changes to its own data store and sends an OK response to Bob. Even if the reply from Jupiter is delayed or lost, the update is considered safe. Because the update is now present on majority of the nodes, the system can tolerate the failure of a single node without losing any committed data. When the log entry is large, moving the log across nodes for a leader election can be costly. The most commonly used algorithm for replicated log, RAFT, optimizes this by electing the leader with the most up-to-date log. In the above example, this would elect Saturn as a leader. So we have another diagram where a new leader commits uncommitted log entries. We'll understand about follower commit based on the high watermark in the next lecture. Thank you so much for watching.